Let's do a quick example using the fundamental counting rule in a real life situation. This example, we're going to talk about passwords. Now, hackers are everywhere. They are a real threat to our security. So we need a very good, secure password to protect our data, protect information, our files, everything. All right. So here's the question. What would be better, having a complex but short password, meaning 8 characters long, but you can have lots of different characters? Or would it be better to have a simple but long password, like 12 characters long, but only lowercase letters? Now, before I go on, full admission, it's better to have a long, complex password. Absolutely. But let's just stick with these two to illustrate a point here. All right. So we're just going to look at the possibilities of a complex but short password or a simple but long password. All right, let's put up a couple of tables here. We're going to pretend like these different boxes indicate the different characters in our password. For a complex password, it's only 8 characters long, so we have 8 boxes. Simple password is 12 characters long, so we have 12 boxes. All right, so let's start off with the complex password. It's 8 characters long. We can have any character, and when we take lowercase, uppercase, digits, and other special characters, that totals up to 70 different possible characters. So for my first character in the password, I have 70 different possible characters that I can put there. For my second space in my spot in my password, 70 different characters can go there. Third spot in my password, 70 different characters can go there as well. 70 for each of the 8 different spots. Following the fundamental counting rule, all I have to do is take the number of possibilities for the first spot in my password, multiply it by the number of possibilities in the second spot, times the possibilities in my third spot, times the possibilities in my fourth spot, all the way, which means I do 70 times 70 times 70 times 8 different 70s all multiplied together. When I multiply them together, I get 576,480,100,000,000 different passwords. That is crazy. That is an insane number of different possible passwords. So me as a hacker, I'm going to have to filter and just guess among all of these 576 trillion different passwords and guess which one, not guess, but incrementally go through them all until I can hit the one that is your password and I can break into your account. Pretty difficult, right? So complex passwords are a great thing. Now, what do you think? Would it be better or worse to have a simple but longer password? Think about that one for a second. What's your guess? Let's go through and do the math. Okay, so it's 12 characters long, only have lowercase letters. That means that we only have 26 different characters we can choose from. Now we're going to follow the same process. The first space in my password can have 26 different characters. The second space can have 26 different characters, and so on. We're going to have 12 spaces, 26 characters each. So we're going to multiply 26 times 26 times 26 12 different times. And what does that come out to be? It turns out to be 95 quadrillion 428,956,660,000,000 different passwords. Yeah, a lot more. So the hackers are going to have a much, much longer list, 200 times as long to sift through to try and guess your password. So in my lifetime, I remember before everyone was focusing, just make it as complex as you can. But then a little bit later, they said, you know what, forget the complexity. Everyone's forgetting their passwords. This is a dumb idea. We don't want complex. We want long. It's more secure. So we started doing longer but simpler passwords. And then they said, you know what, we can be a little bit better. We'll make it long and complex. That made passwords even more secure still. And now we're getting into things like passphrases, where you have not 12 characters, but 12 words put together to be a string, one big long string made of 12 words, which is, that's quite a bit. So uh, the longer it is, the more secure it's going to be. Throw in a little complexity, that makes it even more secure. Anyway, point of this was an application of using the fundamental counting rule in a real life situation. Hope that helps you understand the fundamental counting rule a little bit better. We're going to use this fundamental counting video as we go into the next rules of counting.